Some ice cubes are left in a container as shown below. So which of the following would most likely be observed after some time? Now we have done similar questions before. So first of all, we know that the ice is about 0 degrees or lesser. Alright, so that's the temperature of ice. The surrounding temperature, the temperature of the surrounding air would be between 25 to 30 degrees Celsius. Alright, and we know that we know that condensation occurs and uh, water vapor, and we know that water vapor is a gas, okay, loses heat, right, loses heat, alright, and changes state, uh, changes state into liquid water, right? Need to remember this. We need to know this. We need to understand this in order to answer questions such as this. We also know that evaporation. We know that evaporation is the opposite. It happens when water, which is in its liquid state, okay, gains heat and changes state into water vapor, which is a gas. Okay, so if we know these two and we know these two, then we can answer this question. Okay, first of all, there is no water in the container. After some time, what would most likely to happen? Then there's no water in the container. Now, ice cubes are solids. Okay, so when a solid gain heat, it becomes water. Okay, so when ice gains heat, then it will gain heat because the heat from the surrounding air will be traveling into the area of colder temperature, which is 0. So it will gain heat, but solid, when they gain heat, they will become water, right? So when solids gain enough heat, right, to reach its melting point, right, solid will melt, right, into water or into liquids. So, but in this case, this ice will eventually become water. So if you say there's no water in the container, then it's not really that accurate. Now there are lots of water droplets in the glass dish. So what it is trying to say is that there will be lots of water droplets in the glass dish. Okay. So in the glass dish, there's lots of water droplets. Now this is true because the water vapor in the surrounding air will be losing heat. Right? This will only be true if the water vapor in the surrounding air touches a colder glass dish. But in this case, the glass dish is it's not in contact with the ice, and there would be some condensation, I suppose, but it will not be a lot because it is not in contact with um, the ice. Okay, so it will take some time for even the glass dish to cool down, all right, before you can see lots of water droplets in the glass dish. Option 3, there are tiny water droplets on the outside of the beaker. On the outside of the beaker, there are tiny water droplets. And when that happens, and this is because the container will be losing heat to the ice cubes because it is in direct contact. All right, and sorry, my apologies. Option 3 is there are tiny water droplets on the outside of the beaker. This is the beaker. Okay, you need to be careful is that. So the beaker, according to option 3, that the tiny water droplets on the outside of the beaker. Now this is not true because the beaker will be at room temperature too. So the water vapor in the surrounding air will not be losing heat to the beaker, and hence no water droplets will be on the outside of the beaker. Option 4, there are tiny water droplets on the outside of the container. Now, this is the container. The container will be cool because it is in direct contact with the ice, and it would have lost a lot of heat to the ice, right? And because that, the container will be much cooler, and when the surrounding water vapor, which is about 25 to 30 degrees, surrounding water vapor touches a cooler surface, the cooler surface of the container, it will lose heat, and when it loses heat, the water vapor will change state into water, right? And leaving a lot of tiny water droplets on the outside of the container. Okay, so with that information that I've just explained, make your decision. Choose one of these options for your answer.